We live in a world where we expect everything to be instant. Instant messages, instant search results, instant updates on our feeds. But what's the real cost of that instant gratification, especially when you're building systems that have to work for millions and millions of users? Today, we're going to dig into this fundamental tension in software design, the battle between perfection and performance. Come on, we've all been there, right? You upload a photo, you fire off a comment, and you tell your friend to check it out. And for a few seconds, or maybe even a minute, it's just not there. It's like it never happened. Well, that little delay, that moment of digital lag, that's not a bug. It's actually a deliberate choice, and it's at the absolute heart of how the modern internet is built to handle massive scale. So that little delay is really the result of two completely different ways of thinking. In one corner, you have the instant world, what engineers call full consistency. That's where every single piece of data is perfectly in sync all the time, no exceptions. And in the other corner, you have the eventual world, or eventual consistency, where we basically accept that, hey, updates take a little moment to ripple through the entire system.
Okay, so to really unpack this, we got to get our definitions straight. This is what's known as the consistency dilemma.
So eventual consistency makes a really simple promise. If you make an update and then no other updates happen to that same piece of data, then eventually everyone, everywhere who tries to access that data will see your new version. And the key word there, the only word that really matters is eventually. Could be milliseconds, could be seconds, but it is not right now.
And then you have full consistency. It's the total opposite. And honestly, it's what our brains just naturally expect. When data is updated, all future requests from anyone, anywhere in the world will see that new version instantly. No delays, no questions asked. It's perfect. It's clean. And this is just a brilliant illustration of why eventual is often totally fine. Think about it. When you post something on social media, your friends have no idea that you just clicked the post button. So if it takes a few seconds or even a whole minute to show up for them, it makes absolutely zero difference to their experience. This is a perfect case where eventual consistency works beautifully and saves a ton of engineering headaches.
So, full consistency sounds like the dream, right? It's perfect. But like with most things in life and engineering, there's always a trade-off. There's always a catch. So what exactly is the price of that perfection?
It's the obvious question, isn't it? If we can have perfect, instant, up to the nanosecond data, why on earth would we ever settle for anything less? Why not just make everything fully consistent and, call it a day? Well, here's the deal. Perfection is incredibly expensive. See, full consistency depends on having one single source of truth, one database, one place where every single update has to be written down. And that creates three massive problems. One, it doesn't scale, because everyone has to get in line to talk to that one place. Two, it's slow, for the exact same reason. And three, and this is the big one, it creates a huge single point of failure. If that one source of truth goes down, your entire system, your entire business, it goes down with it. Okay, this might all feel a little abstract, so let's make it super concrete. We're going to take a peek under the hood and see how a massive platform like Wix deals with this exact problem day in and day out.
Right, so modern services like this don't just live on one computer in a closet somewhere. They're spread all over the world in what we call a distributed system. As you can see here, each of these global data centers has a master database and then several slave databases. The easiest way to think about it is that the master is the original author of a book. It has the one single true version. The slaves, they're just really fast photocopies stashed all over the globe so people can read them quickly. Now, to keep things from turning into total chaos, there can only ever be one author writing the book at a time. So at any given moment, only one of these data centers is active for writing. This means all write operations, so creating new things, updating them, deleting them, they all have to go to the master database in that one single active location. So what happens if a user, say in Europe, who's connected to a passive data center, tries to update their website? Well, their request can't be handled locally. No way. It has to take a trip, a long trip, all the way across the network to the active master database, which could be thousands of miles away in North America. And here's where the performance hit really comes in. The source material for this has a beautiful way of putting it. You often have to cross the river 3 times. First, a trip across the globe to read and validate the data. Second, the trip back to actually write it. And then a third trip to confirm that the write was successful. Each one of those trips adds precious milliseconds, sometimes even seconds of delay.
This is exactly why we handle rating data completely differently. To make reads super fast, your request just goes to the closest slave copy, that local photocopy. It's incredibly fast and efficient. But, and you knew there was a but, right? Here's the catch. The data on that slave has to be copied over from the master, and that replication isn't instant. And that is the literal source of eventual consistency. The fast local data you're reading might be just a little bit out of date.
Okay, so that's the big picture architecture. But how does this all boil down to the actual code that developers are writing every single day? Let's take a look. Now, what's so fascinating about this slide is that it actually shows a huge evolution in thinking. See, in the old days, the default was full consistency, the slow, perfect way, and developers had to specifically ask for the faster, eventual reads. But modern systems have totally flipped that on its head. Now the fast, eventual read is the default, and you have to explicitly ask for that slow, perfect, full consistency by adding a little flag like consistent equals true. So the big takeaway here is this. The modern best practice is to design your systems to be eventually consistent by default. You embrace the incredible speed and scalability you get from reading those local copies, and you only pay that performance penalty for full consistency in those rare, absolutely critical moments when you must have the most up-to-date information, right now. All right, so we've got the theory down, we've looked at the architecture. Let's talk about how to actually apply this stuff in the real world. What are the rules of the road for building in this eventually consistent world? Here are 3 key best practices to live by. First, if you have a heavy operation with lots of writes, push it into a background process. Don't make your users sit there and wait for it. Second, your read flows, the way users view data, should pretty much always be eventually consistent. Go for speed. And third, this one's a really clever trick. After you write some data, immediately return the full updated version of that thing to the user. This is great because it prevents them from immediately trying to read it back themselves and possibly hitting that old stale data. But sometimes things get really tricky. Imagine this flow. Your code creates a brand new contact, and the very next line of code calls a different service to send them a welcome email. Now that email service has to look up the contact you just created. If it does a normal, fast, eventual read, that new contact might not exist in its local copy yet, and the whole thing just fails. This is that classic, thorny, I only need consistency sometimes problem. And this is where it all comes home to roost. This stuff isn't just some abstract, nerdy engineering puzzle. The choices we make deep in the system about consistency have a direct and sometimes really confusing impact on the user's experience. I mean, just put yourself in a user's shoes for a second. You add a new product to your online store, but when you go back to the filtered list of new products, it's not there. Or even weirder, you edit an item that's in a list, but because of the way the filter is set up, the update makes it no longer match the filter, and the item just vanishes. To the user, that feels like a bug. It feels broken. But really, it's a product design challenge created by living in an eventually consistent world. So building for massive scale means you have to embrace the fact that the world isn't always perfectly, instantly up to date. The real challenge for engineers and for product people is to build apps that feel seamless and intuitive, even when the data underneath it all is in this constant, eventual state of flux. And that leaves us with one final, crucial question to think about. How do your product's features handle a world that's only eventually up to date? Thanks for tuning in.